Finding areas between polar regions. So this one is find the area inside the circle, r equals 1. There's a circle going around there. And outside the cardioid, r equals 1 plus sine theta. That's the cardioid going around up here and in there. Okay, so looks like inside the circle, outside the cardioid, that's the area requested right in that yellow area. So our strategy, it's like a geometry problem. Take the semicircle area and subtract off the cardioid area in the third and fourth quadrant. And I think you can see that would leave us with the yellow area if you did that. Okay, so we need to find a range of values for theta for the cardioid that create this part here. So one way you can do it is to animate the curve in WinPlot like I've done on other videos, and I have a video instructions on how to do that. The other way is to plot points. So you can key in on interesting points like these where it crosses the axis, and when you do that you find out that pi is an interesting point. That would be this angle coming out here, pi, and when you put pi in there you get 1, so that means the radius comes out at 1 in the direction of the pi angle and gives you a point there. Okay, so that's good. Then moving into the third quadrant, which is so I had mislabeled this point here. It should be 5 pi over 4 coming into the third quadrant. There it is, there's your angle. 5 pi over 4 coming out there. The sign is negative square root of 2 over 2 there. You really have to know your trig well. Subtraction that, you get a very small number, 0.29, and sure enough, only 0.29 out to the point on the curve there, and it's correct. Then going straight down, 3 pi over 2, going into this angle straight down. 1 plus negative 1 is 0, so your radius is 0, so you get a point right here at the origin. Then going on to 7 pi over 4 in the fourth quadrant. Sure enough, you plug in the sign of 7 pi over 4, add to 1, you get 0.29. Again, that's that point right there. And then when you go all the way around to 2 pi, 1 plus sine of 2 pi is 1, so that is the correct point there. And that is 2 pi. Right. Oops. Right there. Okay. So there's your points. So now you know how the curve is being traced out. So it's starting at pi and swinging around to 2 pi. So the region is made by a cardioid, 1 plus sine theta, as theta goes from pi to 2 pi. So what we got to do is take this area and subtract off that area from the cardioid. So that's a unit, half of a unit circle, 1/2 pi 1 squared. Here's your area angle. There's a subtraction sign is from here. 1/2 of your function of theta squared, d theta, from pi to 2 pi. That's your formula for the area. And then if you work that out with a decimal, run Simpson on that integral and subtract it, you get this number here. Okay, 1.2146. Now we're going to do it by hand because we could be required to do that. So here it is. I squared out the 1 plus sine theta because I think some easy parts of the integral would be there. You can see this where it happened, just taking the integral of each of these pieces, just working on the indefinite integral first, the antiderivative. It comes down to needing this again. We've seen this before. The sine reduction formula for n equals 2, because that's a 2. And we just plug in the number 2, work it out, you get this. So that then this integral here is going to be theta this, and minus the answer to, or plus the answer to the previous one, which equals this. So the area is going to be from the previous quantity, which was up here, right here. We were here. We were doing this integral. Just copy and paste that down here. That's this one. Plug in everything that the integral was equal to. Evaluate it at pi and 2 pi. And everything works out. Simplifies down algebra. Just look at the algebra. All simplifies down and ends up with this. This is the exact value of that area. And when you do the calculator on that, it's 1.2146, and that's the number that we got up top, so that verifies.